All right, so we're going to talk about permutations. We're going to talk about combinations, okay? So a permutation and a combination are going to reference when we are pulling from a group. So a permute, that says T-A-T. Let's just cross that out. Permutation and combination. And it means you're pulling from a group, okay? What you need to recognize is that with a permutation, order is important. With a combination, order is not important. Okay? So with a combination, order is not important. But the basics, we're going to look at the basics of what these things mean first. Okay? So what I have is, let's give you a scenario first. Actually, let me talk to you about one more thing first. We need to talk about what a factorial is. So a factorial is an exclamation point, but it's also a mathematical symbol. So that factorial simply means you're going to have n factorial, okay, whatever n is. N is going to be a natural number. It's going to be a counting number. So for instance, if I tell you, well, let's find out randomly what 6 factorial is. Okay, what you do is you take this number and count backwards to 1 and multiply it all together. In other words, 6 factorial is the same thing as 6 times 5 times 4 times 3 times 2 times 1. So I take this number, count it down to 1, and multiply it all together. Okay, so 6 times 5 is 30. 4 times 3 is 12. So 30 times 12 is going to be 360. And 2 times 1 is 2, so 360 times 2 gives me 720. So 6 factorial is the exact same thing as 720. Okay, so factorials are the fastest way that we can use a pattern or a formula to make numbers grow. And we're going to use factorials when it comes to permutations and combinations. So let's talk about the symbolism first, and then I'll give you some context to kind of sort of get it in your head what we're talking about. So for a permutation, what we're going to use is this notation. I threw my notes away. This notation of P with a capital N that looks like an exponent, and then a lowercase n that's a subscript. And that means I'm dealing with a permutation. Okay? The formula for that is going to look like this. And it's going to be, hang on, looking at my notes, n factorial over big N minus little n factorial. Okay, so what on God's green earth does that mean? I'm going to give you the formulas first, and then we're going to come back and look at this stuff. So we just addressed what a permutation is. In other words, order is important. And now we're going to do what a combination is, where order doesn't matter. Okay, so a combination, what we could look at, and another way to do this, okay, depending on your textbook, is you may have a capital N as a subscript, then a big P, and then a lowercase n as a subscript. Okay, so that's another way to write this. Now, a combination, we're going to use a different notation. So your combination is going to look like, I could use this notation, so it would be a capital N and a big C, and then a lowercase n. Or we can use parentheses. So if we're going to use parentheses, we'll have parentheses, a capital N, and a lowercase n. And pretty much as soon as I see this parenthesis thing, I know I'm dealing with a combination. Okay, so notice this looks like a C right there. That parenthesis looks like a really weak C. So that's your combination, and that's how I tell them apart in my head. Now, this formula is going to be a capital N factorial over little n factorial times big N minus little n factorial. So you notice it's the exact same thing as this one. It's just that I threw a little n factorial in as well. So the permutation order is important, and it's this part. The combination order is not important. It's the same thing, but we also divide by n factorial, little n factorial. Now, for the love, what language are you speaking? Let's talk about students. So let's pretend for a second that I've got 10 students. Okay, so remember, permutations and combinations, I am pulling from a group. Okay, I'm pulling from a group. For both permutations and combinations, I'm pulling from a group. So what I have then is I'm going to use 10 students. Let's just say my enrollment is 10 students, and the first 3 that walk in the room, I'm going to give them scholarships. Okay, so student number 1 is going to walk in the room and get a $10,000 scholarship. Student number 2 is going to walk in the room and get a $5,000 scholarship, and student 3 is going to walk in the room and get a $2,500 scholarship. So you should recognize right now that order is important. Okay, so we're going to use Joe, and we're going to use Sam, and we're going to use Chris. Okay, so those are my 3 students out of the 10 that we're just going to focus on for right now. If Joe walks in first, Joe's going to get 10,000. But if Joe walks in second, Joe's only going to get 5,000. So order is important, okay? Because Joe, Sam, Chris is different than Chris, Joe, Sam, right? All right, so that means we're going to use a permutation. So what does this mean? Let's come back up here and look at this permutation. So my permutation says I'm going to have n factorial, which is the number in my group. I have 10 students, okay? So I'm going to have n factorial over big N minus little n factorial. So what that means is I've got 10 factorial because I got 10 students. And then I am going to take big N minus little n, which is going to be 10 minus how many students am I giving scholarships to? I'm giving them to 3. So that gives me 10 minus 3 factorial. So let's simplify this a little bit. That means what I've got is 10 factorial over 7 factorial. Okay, so 10 minus 3 is 7. Now what that looks like is I've got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, that's 10 factorial. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 over 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, all this is a multiplication over, this is just a big ugly fraction. And any number divided by itself is 1, which means I've got all of these that reduce to 1. What that leaves me with is 10 times 9 times 8, which is going to be 720. That has nothing to do with this, okay? That was just a happy accident. All right, so I've got 720 different ways for 3 students out of 10 to walk in my classroom. There are 720 different ways for that to happen, okay? And so that extends to the full 10 student enrollment, just not the 3 names I listed. So that's what that means. Now, if you're using a graphing calculator, okay, what you have is if you click math, let's see if I can make you focus. Oh, that's a little bit better. If you poke math right here, okay, scroll on over to probability. And first of all, option number 4 is factorial. Okay, so option number 2 is for a permutation. Okay, so what I could have done is, first of all, go back out to your home screen. How many do I have? I've got 10. Okay, how many am I choosing? And that's going to be this permutation. So I'm going to go to probability and choose 2. And do you notice it made a little subscript right there for me? So I've got 10 students. I'm doing a permutation where order matters. And I'm choosing 3. Okay, so don't use the 7. That's if we're applying the formula. This is doing the formula for me. So I've got 10, choose 3, and I've got 720. Okay, so that's if order matters. What if order doesn't matter? That's what combinations are going to be. So notice I've got this little additional thing here. So let's do this for a second. What I have is let's use the same scenario. Okay, so the first 3 students in the room, I'll get a $25 Starbucks gift card, okay? So in other words, I don't care if, who are my names? If Joe comes in first and then Sam and then Chris. they're each going to get a $25 Starbucks gift card. So if Sam comes in first, and then Chris, and then Joe, my result is the same. So in this case, order doesn't matter. So what I need to do is divide out all the repeats. Okay? So the first 3 students are going to get a Starbucks gift card. So what I could do is say I've got 10, choose 3. So notice I'm doing combination this time. Or I can recognize that that is now 10, choose 3. So this is my little parenthesis that looks like a C. So it's combination. And what that looks like is this. I've got 10 factorial over how many am I choosing? I'm choosing 3. And then the other part is that 7 factorial. Okay, so this was my permutation when order mattered. Well, I've got this 3 right here. Okay, so notice that if I add the 3 and the 7 together, I get 10, which is my numerator. So what does this look like? What this looks like is I've got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? That's my 10 factorial, over 7 factorial, which is 7, 6, 5, 4, 3, 2, 1. But I also have a 3 factorial, which is 3, 2, 1. So I've got 3 times 2 times 1. What that's going to do is it's going to divide out all the repeats. Okay? So instead of recognizing that Joe, Sam, Chris is different than Chris, Joe, Sam, it's going to say if these 3 people walk in, it's going to have the same result. So it's going to divide out the Joe, Sam, Chris, Chris, Sam, Joe, Sam, Chris, Joe. It's going to divide out all that and only count for it once. So that's the difference between a permutation and a combination. Well, any number divided by itself is 1. And so now I've got a 3 and a 2. So if I divide out the 3 from the 9, 9 divided by 3 is 3. If I divide out the 2 from the 8, 2 divided by 8 is 4. And 1 divided into anything doesn't change. So now I've got 10 times 3 times 4, which is going to be 120. So now there's, instead of 720 different ways, there's only 120 different ways when order does not matter. Okay, when order doesn't matter, there's going to be less possibilities for outcomes because of those repetitions that are there. So what is your calculator going to do? Your calculator is going to say, I've got 10. Okay, well, I want to go to math, probability, and choose combinations this time. And notice it's going to do my little subscript for me. But I'm doing a combination. I still want the first 3 students. So I'm not using a 7. I'm not using anything. I have 10 in my group. I'm interested in 3 of them. So when I do that, I end up with 120. Okay, so that's the difference between combinations and permutations. You'll see this notation for combinations in your book. But this is also an acceptable combination, or an acceptable notation. Just notice that for permutations, order matters. For combinations, order doesn't matter. And that is section 4.1.